All right. Welcome, everybody, to today's show. We got a good one for you, so get ready. What are we doing today? Well, we are talking about the best analytics strategy isn't just build or buy, it's custom meets composable. A lot of people ask me what this word composable means, and we will define it today and help you understand how composability is the key to solving this problem of what should I build versus what should I buy when I'm building an analytics stack. So we've got a really good show for you today and excited to get through it. So what are we going to talk about? Well, we're going to cover the basics of build versus buy. We'll teach you about composability and how it helps solve this problem. We'll get into some conversation a little bit about AI and does that change things when it comes to thinking about how to assemble a data stack? And then we'll talk about the build versus buy decision-making guide. So what are the key points you need to understand and answer in order to make sure you're getting the right mix of tools to deliver your vision? Of course, I am your VP of Product Strategy here at Good Data, Ryan Dolley, and I'm excited to be joined today by Pavel. Pavel, why don't you go ahead and introduce yourself?
Sure. Hi, Ryan. Hi, everybody. I'm Pavel. I'm the principal solution architect from our Good Data team. And prior to that, I spent quite a long time, actually over 12 years, working in a global technology consulting company, mostly in the area of data and BI. So happy to be here.
Yeah, it's good to have you, Pavel. So Pavel's going to help us, give us kind of like the real world experience implementing these kind of systems as we go through it. So I'm really excited to have him on the show today. Of course, if you've been here before, you know, but just as a reminder for everyone, everybody's muted upon entry. We do have a Q&A section, and I am doing my best to monitor it during the presentation. And we at Good Data do not like you to hold your questions to the end because that's boring. So get your questions in, and Pavel and I will try to answer them as they come up. So do that. And then finally, there'll be a follow-up email with a copy of today's conversation so you can watch it again and share with your friends. So real brief before we get into it, of course, who are we here at Good Data? Well, we're the analytics product platform. I like to describe us as the analytics platform for when good enough is not good enough. And what I mean by that is we're really focused on giving you the features, capabilities, and tools for you to realize your vision when it comes to analytics. And how do we do that? Well, it's with a combination of really great out-of-the-box low-code, no-code interfaces for data modeling and viewing and consuming dashboards and building visualizations, but also a foundation of kind of engineering excellence built into it. So that's APIs, SDKs, all of that. And then to top it off, we have really powerful AI capabilities that we're continuing to build in through the whole platform. And also, we have a super high-performance data platform and computation engine built into it where you can house your data with us. We can transform it and really in like a super multi-tenant way. So all of that is to say, our goal is to give you the tools to build the exact right thing for your customers rather than having to settle for something that's just good enough. And that's really where we shine. So with that said, I will just check to see, do we have any questions? Not yet. Okay. And then let's get into it here, Pavel. So today's topic is build versus buy. And I think this is actually a really important topic. I get asked this a lot, and many teams face this decision when it comes time to start building, especially customer-facing analytics. Oftentimes for internal analytics, teams typically feel pretty comfortable with the buy option because you get a strong vendor support, and we'll get into this, you get strong vendor support and you get a known product, right? But when it comes time to start trying to monetize your data, they often find that whatever tool they have is not flexible enough and cannot deliver that vision that will enable them to start really seeing ROI on the data from outside the organization. That's often when this decision comes up. Sometimes it comes up for internal analytics too, but that's most often where I'm seeing it. And so, what does that really entail? It simply put is, are you going to try to build your analytics stack off of open source components and kind of software engineering components, or are you going to build it on top of tooling provided by commercial vendors? And this is not an either or, where you can mix them together, and many people do. But ultimately, that's what it comes down to when it comes to time to make this decision. So we're going to walk through the advantages and disadvantages of choosing to build versus choosing to buy for the next 10 minutes or so. And as I said, if you have questions, go ahead and get them into the chat. I will try to answer them. Pavel and I will try to answer them as we go. So you have here what we kind of call the build data stack. And the important thing about the build data stack is not really what any of these individual tools are. The important thing to note is that what you're really looking to do here, if you go like pure build, is you're going to choose open source components, charting libraries, computation engines, all these sorts of things. And you are going to, through your own engineering skills and with your own software and analytics engineers, build the data platform yourself. And as you can see, there's a lot of decisions you have to make and a lot of different layers to the build data stack. You're going to need storage. You're going to need processing. You're going to need a query engine and computation. You need visualization and some sort of AI. You're going to need to choose AI and ML tools. And then you're going to need to wrap all of that in infrastructure and DevOps and data ops. And every single one of those points is an individual decision you're going to have to make about which tool is best. And then you're going to have to assemble all those tools together. And I use the word tools. I mean, these aren't really tools, right? We're really talking more about technologies and libraries at this point. But you're going to have to assemble them all together, stitch them together into a coherent data stack that helps you deliver whatever your analytics vision is. And so, there's some pros and cons to this, but I'd like to bring Pavel in at this point. Pavel, like, what's your history with this way of working?
Yeah, like what we often see in this kind of build approach is that you start small, you start with some, use case, some solution in mind, and you start in building the solution, the platform, right? So initially, it's perfectly fit for the initial purpose, yeah, because you know what you need, you know the requirements, you know how to size it. You perhaps have the skills. That's going to be the sooner or later. But what quickly becomes is that it becomes very difficult to further extend or scale, because you start with some use cases, but then you have another use case, and you want to add another use case, and you want to plug in the AI. And suddenly this initial architecture might actually become a burden for you.
Yeah, I've seen that a lot in my career too. It's very good, and let's talk about the pros and cons of this approach. It's very good at getting you exactly what you want, especially in that first deployment, because you're choosing all the tools and capabilities to specifically do that first vision. So like you said, that first launch, when you choose the build option, you'll probably look at it and say, man, it may have been very hard, and oftentimes it is, and we'll talk about that. But because we chose to build our own stack completely, we got exactly what we wanted. And it gets when I say it's easier to swap pieces in and out, what that really means is you don't have vendor lock, right? Technically, it could be challenging if you say, you know what, we're going to ditch, we've been using Postgres and we're going to switch to DuckDB, which is maybe a smart choice to make. Doing that could be very technically challenging, but you're not facing contract negotiations and RFPs from vendors, and the vendor who you're trying to move off of is doing everything in their power to stay within your data stack. You are kind of the king of the castle here, and you design the castle the way you want it. But the downside is the skills to do this are very expensive, and finding the talent to do this can be very challenging, especially depending on what market you're in. If you're in San Francisco and a couple other global tech cities, it's probably pretty easy. I'm in Detroit. In Detroit, doing this all on your own would be pretty challenging. We don't have the engineering skills when it comes to data systems in Detroit that make it very easy. If you want to build a car, yeah, we have the engineering skills for that for sure. There's lots of knobs to turn, which means there's lots of things to break. So there's nobody looking over your shoulder saying, hey, actually, you shouldn't do it that way. It's going to be you talking with ChatGPT and going to Stack Overflow and asking questions in order to try to solve these problems. And then finally, when you do mess it up, there's nobody to call, right? Because you have no vendor support when it comes to the build approach. You are on your own, and that with all of the power and flexibility and the kind of pitfalls that may entail, because you're going your own and assembling your own data stack. And so, this is kind of from my perspective. Pavel, is there anything I missed, like pro or con, that you would say when it comes to just rolling your own stack, as the kids say?
Yeah, like I think if we look back at the slide before, like this platform is really complex. It has many components, but not only technical components. It also has like, you have to set up some governance. So, just building the governance right at the first time is really difficult because then you deliver the first part and you talk about the AI, you talk about other use cases. And now you actually need some consistent governance model to be sure that your users, and especially your external users, your client users, have the correct, data access and everything. So it's even this part, I think, extremely important and difficult to build. And another example that I saw multiple times is like to provide like multi-tenant, really large-scale analytics, like for your external clients. It's a difficult task. If you, for example, take some shortcut, let's say you provide the data, you kind of provide it in a correct segmented way, so each customer has its own data available, that's perfectly fine. And then you want the clients to extend it. Well, maybe in the first place you say, okay, so here are the data, here's the model, here you have a SQL, just plug it into here, and you can just create whatever you need on top of that, or whatever you need from your perspective, which makes sense. But what happens in large scale over not so long time is that you want to change something, you want to update something. It becomes basically unmanageable with this approach because your clients, they already set up some routines, some process on their side, some reports, data sets, whatever, and you want to change that. Maybe it's correct because it was wrong, but how do you propagate this level of updates in such a large scale? Like, for example, so this was kind of an example, you basically omit the semantic layer. So if you do that, it's very difficult to take this to make it right, because so that's
Yeah.
what we see.
Yeah, and that's an important part of our architecture. That semantic layer, I think, is one of the keys to making the scenario you described much easier. Where you have more ability to swap things out without breaking stuff downstream when you have that semantic layer kind of existing between the data and the analytics objects. That's really critical, and I think it's something people leave out very often when they choose to build their own data stack. They don't think about that, so they're building all the analytics objects, and the self-service users are all directly accessing the database instead of going through some semantic layer, which kind of abstracts away that database. It makes it easier to understand, but also, when you decide, hey, we're going to swap Postgres for DuckDB, actually, if you have a semantic layer, you can swap the underlying database engine, and no one downstream even knows necessarily. It's one of the major advantages of semantic layers and what we offer here at Good Data.
Good that we actually have a client that did just that. So they had a large model built in our semantic layer sourced from Snowflake. What they were able to do themselves was basically switch to Databricks within weeks, which is like unimaginable if you were on your own without this layer. Like, how would you do that? So
yeah,
definitely important solution.
No, it's unimaginable is the right word. I have participated in the past in some attempts to migrate databases and analytic systems, and it's not fun if you don't have something like Good Data semantic layer there that's helping you with it. Okay, so those are the pros and cons of build.
One more, I wanted to add to that. It's like from the technical perspective, or like requirement perspective, it might happen that, as usual, requirements evolve. So imagine you initially build it, you want it daily, hourly reporting, but suddenly there is a use case that needs maybe the same model, part of the model. They want it every 5 minutes. Maybe they want it real time. And that's when, this build model means that, okay, how do we incorporate real-time data to that solution? Did we even think about it? Like, probably know. So yeah, you can literally get into many caveats over time.
Yeah. Excellent point. So now let's look at this is the build option. Now let's look at if you choose, we're going to go 100% the opposite direction. We're going to buy everything. So we're going with, the commercial vendors, or in situations where there is an open source option, there's also, the commercialized version of that open source that you can purchase. And what that looks like, is a data stack much more like this. So right away you'll see, oh, it's way simpler, right? And that it is simpler in terms of there are fewer moving parts. The reason, or rather, the moving parts are provided by fewer people. There still may be many moving parts, but your storage and your computation and your data caching, for example, can all be done by Snowflake instead of you having to maybe choose 3 different technologies for those things, like you might have if you're going purely with the build approach. And so this is something, this is a much more common, this is probably a very common buy data stack where what are you going to do? Okay, we're going to land raw data in something like S3, and using Airflow, we're going to move it into Snowflake. Once it's in Snowflake, we're going to transform it using dbt in order to get it into shape for reporting and analytics. And then we're going to use a commercial BI tool like Looker or Good Data. We have lots of people who have this data stack and put Good Data on top of it in order to present the outputs to our users. And so superficially it looks much easier. There's still a lot of integration work you have to do, but the vendors do a lot of that for you, wherein instead of having to do some API level integration that you write, a lot of the vendors you see on the screen here, it'll be a button in the UI. You say connect to Snowflake, you provide the connection information, and now dbt is pointed to Snowflake. You didn't have to write any code in order to make those tools work together, which is one of the advantages of this approach. So this is simpler to set up and maintain. And one of the reasons for that is what I just mentioned, that the vendors have already pre-configured a lot of the integrations for you. They've figured it out for you. And also you get support from the vendors. So if something does go wrong and you have a contract with Snowflake, you can go to Snowflake support and say, hey, I need some help with this. What can you do? It in theory requires fewer skills to build, and that's not. It's not that it requires fewer skills in general, but I would say it requires a less sophisticated degree of engineering skills, the ability to interact with APIs and that sort of thing in order to put this together. The cons here are it's a lot harder to get it to do exactly what you want, because of limitations, particularly at the BI layer. A lot of the old school BI tools that people choose when they're just buying everything from vendors, they just don't have front end flexibility. They're not built in a way, their embedding options are usually quite poor. Their API support is usually quite poor. And so you're really stuck in what I call a sideshow. And what that means is that when it comes to your analytics applications and your apps in general, there will be kind of a button or a folder or something where the customers have to go to see the analytics, which is not the best way to present that. That's kind of an old school way to do it. Much more modern would be to embed and integrate the analytics into every part of your app. So your users don't have to be doing their operational work and then go over to the data part of the app to look at the dashboards and then go back to their operational work. That kills flow. And users, that user experience was acceptable 10 years ago, but increasingly it's not. People want to be able to have access to the data in the same place where they do their working and thinking. And this stack is a lot harder for that. The other thing, and I guess I should have put it on here, but we're missing an X, which is this can also cost a lot of money. Is the other part of it. We've all, if you've been in the data industry, you've heard all about the year 3 Snowflake bill horror story, right? And so that's the other side with when you're buying from commercial vendors. you have a bunch of contracts to negotiate, and all of them are looking to increase the ARR of that contract over time. And so that's a downside to that too. That's just my opinion though. Pavel, you actually build these things.
Yeah, like I the whole time you explained this, I was just thinking about price, cost, But especially like I worked a lot in the data layer, let's say, preparing data, the warehouses, etc. And like working with Snowflake, for example, is great. It's very simple, easy to use. We have a lot of support, but we try to build even a couple of like complex pipelines and solutions in Snowflake, and we often begin to play this kind of where can we save the cost game? Like, do we save on the compute? Okay, we do this. All right, we save on the compute, but we have that issue. We need to do it like, let's say, real time or very small batches. Well, that's going to cost us on some different type of cost. And suddenly you will start hitting the wall between cost, performance, scale, and you are just rolling over because those like platforms like Snowflake, they have a really great price. I have to say, I never saw such a like really covered pricing for any kind of optimization you might think about. So yeah, there's definitely something you need to think about when just purely buying, because it will just lead you to where you have to go. So
Yeah. Yeah, absolutely. And I will say, in the course of my career, kind of coming out of data warehouse and BI teams is where I cut my teeth in the first part of my career. We bought everything at that point. And so this is something I'm really familiar with, the struggle of vendor management that comes along with this option. People say you get what you pay for, and you do get support from vendors, and oftentimes that's worth it. But the flip side is they have their own agenda, and now there's someone with their own agenda who's in your organization, and that's realistically, it's just one of the downsides to this. So with that said, is there anything else I'm missing before I move on to the composability part of the presentation, Pavel?
and I would say also when the selected part of the data stack, let's maybe stay with data layer, doesn't suit you anymore. So let's say you want to go from Snowflake in terms of the transformation and all the stuff you need to do there somewhere else. Well, that's pretty difficult. So without like open architecture, you basically have to do quite a difficult migration project, design the other solution that you do, and it's really complicated.
Yeah. I've participated in back when I was consulting, I helped a client with an Oracle to Snowflake migration. And it took multiple years. And then at the end of it, they were on Snowflake, which was their agenda was we have to get on cloud. So now we're on cloud. Great. But they found themselves in the same situation they were in with Oracle, right? Where exactly what you described. Now they're locked into Snowflake. And 5 or 7 or 10 years from now, if and when some new technology comes out and they say, we want to move to that, well, they're locked into a proprietary architecture in a lot of ways. I understand Snowflake and Databricks are embracing open table formats and stuff like that. But at the end of the day, I think they want you in more and more. They want you in their commercial products where it's hard to leave. And that's just the reality of it. Okay. So let's talk about composability. This is a word that comes from the engineering world, software engineering. And it's relatively new to data. I think when I first started at Good Data and we were talking about composability 3 years ago, I often would be talking to people and they would just have no idea what the word meant. And thankfully, I think that's changing. But we still have a long way to go before everybody really understands what composability means. And so the way I like to explain it is really that composability is kind of combines build-like elements of code and engineering, customization and integration with buy-like elements of pre-built interfaces, pre-configured services, and if you're choosing a composable vendor, the vendor support that we talked about earlier. But at the end of the day, I'm a Lego guy. You can't see behind my virtual background, but there's tons of Lego back here. It's like a Lego kit, right? Wherein you get the Lego kit, and with the bricks, you can assemble a space shuttle, and with the same bricks you could assemble like a bridge or a skyscraper, right? And that's really what it boils down to is composability is the idea that you're going to build modular components, and you're going to use those modular components. You're going to have a library of them, and you'll be able to assemble them as needed in order to support a particular use case or deliver a particular product. And that's the way to think about it. And that's what makes us special at Good Data is like we are architected for composability first. And we'll talk about how that kind of helps you solve this build versus buy problem. But before I do that, I want to kick it to Pavel to get your thoughts on composability and composable approaches when it comes to building and implementing data stacks.
Yeah, I think the composability is really key here. Like even in our customer implementations we are running like every day, it's important to start small, deliver fast. Yeah. So what we always have to do is, okay, we have some initial use case. We helped the client to build it within basically weeks, right? But what we need to be sure that this initial part, so let's say we create the first part of a semantic layer, we cover some business domains that are needed for that, and then we build the use case on top of that. Let's say it's just a dashboard or a couple of dashboards with some source stories. Okay, but the thing is, the nice thing about the composability is that we get another use case and we just keep reusing the same thing we built previously. We don't have to create, duplicate the same tables, or what I often actually saw before even joining Good Data in the old Good Data warehouse projects. Yeah, so there is a business. One side of the business, they get nice business table with all the details about the customer. There is another department and they say, hey, we just need, this a bit differently and a little bit more attributes. So what did we have to do? Create another version of that large table for customer because it was sliced a bit differently.
Yeah.
And I'm not even going to those labs or those kind of things, but it was really duplicating all of the logic and business logic stuff in the multiple places. And that was a mayhem. So I really love the composability we offer, and it helped us a lot to deliver fast.
Yeah, that's the key thing to understand, I think, with composability is it doesn't mean it is not copying, right? So like if reusability is a core part of composability, but it's reusing the same object, the same code, so it's not, say you have the easiest way to understand it, I think, in terms of BI at least is, the way Good Data is architected is that the charts are independent of the dashboards. They're separate objects. And what that means is that one chart can be in 10 dashboards, for example. So say you come up with the way we like to view our, ARR, right? There's with the colors and the line and however you want to view ARR, there's the way you want to view it. Well, obviously that's an important metric. It's probably going to be on a lot of dashboards. In a non-composable system, you would recreate that same chart on all 10 dashboards. And then when something needs to change, you would have to go back into all 10 dashboards to edit it, to make that change, right? Whereas in a composable system, the dashboard and the chart are separate objects. The chart has its own, it exists outside of the dashboards, and they're linked. So those 10 dashboards reference that one chart. And when you update that one chart, it automatically flows through to all 10 dashboards. I think that's the easiest way to understand it, purely in terms of the BI front end, right? Is like the objects, again, are like Lego bricks, and you can assemble them how you want. But wherever they're used, they maintain a consistent lineage and a consistent definition, so that if you change that definition, it automatically flows through to any place where that object is used. And this is what allows you to do what Pavel talked about, which is, hey, we're going to start small, we're going to get that first win, but then we can use those components of that first win and just continue to build on them and build on them and build on them in a way that allows you to make sense of it all, right? Where you're not copying stuff and you're not having to update 10 specifications because that chart or dashboard or table was so useful that you ended up replicating it over and over again. All that goes away. And now you're kind of maintaining a much more coherent system where all the content exists in just one place, has a single definition, but then can be reused over and over again. Did I get that right, Pavel?
Yeah, absolutely. Like even I just remember yesterday, actually, I had the exactly same conversation about we had to update some kind of metric, and this metric was already used for reports generated for Q1 and Q2 for like thousands of clients. And the question is like, okay, the fix is easy. Here it is done. And the client asked, okay, so now we have to regenerate all the reports. I said, no, we just push the button, deploy it. It's going to be updated everywhere you are because it's managed by the semantic layer. It was like,
Exactly.
that's great. Perfect. So yeah, it's not just for the BI layer. This is the semantic layer. So all the other parts connected to it will be updated as well automatically.
Exactly. Because our semantic layer, you can point almost anything to it, right? So yeah, our BI will be updated, but also your custom apps that point to that same semantic layer will be updated.
Or your AI agent.
Yeah, right. Because the AI agent uses the same semantic layer. And we haven't talked much about AI up to this point, but I think it's worth just having a conversation about it. Does everything we've talked about so far apply to AI too?
Absolutely.
There you have it. Simple answer. No, I mean, this idea, one of the interesting things about AI that we're seeing is, I think, and this is going on with our development of the AI assistant within Good Data, which if you're a customer of ours and you haven't tried it yet, try it out. But you don't want your AI every time someone asks a question generating a new chart when an existing chart exists. That could answer that question. You already have it. You have a human authored chart that is right. You want the AI to be able to go and pull that chart and display it when the end user asks a question, for example. And like composability is at the heart of what enables that. The composable architectures are really good for AI because AI can easily search it and find the right content, and it doesn't have to search through tons and tons and tons of duplicate content or content that is semantically so similar as to be almost indistinguishable. AI is going to have a really hard time grabbing the right one in that situation. But if you've designed with composability in mind and you have a composable architecture, well, then there's one canonical definition of that chart, and AI can easily find it and surface the correct one. And that's something, just a small example of like, how does this play into AI? Well, that's one of the ways it does it. Is by making it easy for AI to find pre-existing content instead of constantly generating new content.
I would just add to that this pre-existing content was previously created, verified, and is managed by your data team. So it's not like something that AI just generated some SQL and called the metric and use it. It's really something you manage, and then you just leave AI on top of that to serve the use case. Because we also heard about use cases like, okay, and there are tools like that say, okay, based on the AI prompt, it will automatically go to your data, go generate the SQL and give you an answer. I would just ask, like, would you be confident as of today to let your business depend on such SQL query to somewhere? So that's why the semantic layer is definitely a big advantage of the whole architecture. And again, it's the same verified, tested, and managed semantic layer for any other use case, not just AI, but also BI and the other stuff. So
exactly. So we've talked a lot about composability. What does a composable data stack look like? Well, at Good Data, this is the heart of what we've built. So we really have three layers or modules to Good Data, or three components, I guess I would say, of the platform. We have what we call the analytics lake. We have Good Data Artificial Intelligence and Good Data Business Intelligence. And all of these elements have been built in this composable way, meaning that whether you're using our AI, for example, the elements of our AI, the chatbot and the searching capabilities, are available to you to be used within our user interface or embedded within your user interface, or as an API endpoint for you to interact with, for example. And so no matter where you want people to consume the AI capabilities, they're coming back to the same point, right? You're not replicating AI capabilities across applications. It's the same fundamental architecture that's powering them all, and then you can choose how to deploy it. The composable data stack is really kind of, especially the way we're doing it here at Good Data, it is a holistic data stack from a single vendor. We have all these components, we've pre-configured them for you so that they work together, but we've designed it in a modular way, and we're using kind of industry-leading open source technologies inside of it. So there's nothing proprietary. If you're using our analytics lake, you're using a combination of Iceberg, Arrow, DuckDB, and StarRocks. And those 4 technologies are open source technologies that are portable. If you decide that you want to move, you want to move some of that data out of good data, well, it's already in an open source technology, and you can move it to self-managed open source instead of us managing it. And so this is really our approach, and we take that modular building block approach. We take the best open source technologies and our good data authored kind of front end components, and we really assemble this composable data stack out of it. And now, Pavel, this is like, you're probably the expert in building on these things. Can you share some stories about your experience building with this technology?
Yeah. I would even add even the things around it. So your architecture, your IT architecture, data architecture, it's quite easy to plug it in. So far we spoke about, the BI layer, the semantic layer, AI, but that is always this technical integration. So how easy it is to plug in good data into your architecture. And for that, we are building, like in professional services, the projects basically for large scale enterprises and clients like that. So we actually have to deal with a lot of different type of architecture. We are able, to integrate the automatic governance layer, provisioning of users and permissions. The client already have event-based architecture in Azure. And we just plug it in because we have a Python SDK, we have the API approach. So within weeks, we are integrated on their current architecture. It didn't even need to change anything, basically, just to plug it in. Similar to things of how do we manage this kind of analytics at scale? Well, we have an integration with GitHub because our analytics is as a code. So there is such an easy thing just that we can take wherever you see in your workspace, your visualizations, your metric layer, we can just use it as a code, put it in the GitHub repo, and just treat it as any other component that you treat with the SDLC process, right? So it's that easy. That's what I think is bringing even more value and lets you, onboard much more easily into our solution.
Yeah, that I think in particular, I've seen a lot of our customers end up having some degree of like in-house data sources, right? They have some sort of, they have an app, and that app is throwing off data via an API, and it's just so easy to integrate that data directly into good data rather than having to land it and transform it within something like Snowflake. Like we can do a direct API integration, and if we want to land and transform it, well, we have the tools available with DuckDB and that sort of stuff. It's all sitting there ready for it. It's just such a huge advantage to that. Now, we have a question from Michael. Michael asks, "What about data quality?" So, how does this approach help with data quality, if it does?
Well, I think the semantic layer and the data model you build in the semantic layer itself is a perfect base to actually do like some automated tests of the data quality, because in our model you can define the primary keys, the standard relationships, like the standard data modeling. So it's easy basically to say, okay, let's generate some kind of tests and just make sure that we have the unique keys and the reference integrity. Even if you want to define some business rule, it's quite easy to today generate such types of executions and just put it into your CI/CD pipeline if you wish. Yeah, just to run it with every PR, you will just run a couple of tests on the model, on the data, and make sure that the change you are bringing is not breaking anything.
It really falls back to that kind of engineering approach to analytics that's at the heart of how we build, I would say. You can test analytics like software if you have the tooling available. And that's what our most successful customers do. So they, the deployments that end up breaking something critical, right? Those tend to go away when you're treating software like, when you're treating analytics like software. Great question, Michael. If anybody else has any other questions, of course, please ask. We're happy to answer them as we close out today's presentation. So the pros and cons of composability. Well, in a lot of ways, it's a best of both worlds, I would say. Like with good data and with the composable approach, you're going to have a number of off-the-shelf components that are just ready for you to be deployed how you want them. For example, we have a BI environment, but the components of that BI environment can be deployed into your software at a very granular level. So what I mean is our chatbot, you can just take just a chatbot. You say, I don't want the rest of the BI environment. I just want the chatbot. I want that in my app. Great, you can do that. If you want our drag and drop interface, independent of the rest of the BI environment, you can put that in your app. Our scheduling and alerting capabilities, you can take those UI elements and put them in your app, skin them and put them in your app so they look like a native part of your app. That's just a small example of kind of how it's the best of both worlds. So you get a lot of the out of the box stuff that you'd like from a vendor, but it comes as a toolkit in addition to being a holistic environment. The individual components of that environment are available to you for you to use how you see fit. And that's really what composability means. It means it's out of the box plus easy customization. And of course, if you choose a composable vendor like Good Data, well, you get support, right, from us when you're using the software. Are there cons? I would say it still requires engineering skills. So it's if you truly have none, and we'll talk about that on the next part of the presentation, this approach, may not be the best for you. But it's also, I will say, I've worked with a number of customers, but that have used us as like an on-ramp to engineering. So they come from a very old school BIDW workflow. And when they chose us as their vendor, then they started skilling up, okay, how do we use APIs? How do we do CI/CD and data ops? And they've transformed into a much more engineering focused organization. I would also say this works best if you have a vision, right? And what I mean by that is, look, if you don't have a vision of what you're trying to build that has to be just right, then it may be that something just good enough off the shelf, just kind of your same old dashboard experience that we've had for the last 10 years, maybe that is what you need. But if you do have that vision, well, then the composable approach will help you achieve it fast and scale it. And that's the most important thing about it in my mind. Pavel, I will see two things. We have a question, so I'll ask you the question. But first, is there anything you would like to add to the pros and cons of composability?
I would just add to your last point, basically, that I have an example that's proving actually that. So we first had the first part of the implementation was basically to switch from kind of here are the data and do whatever is needed with it. And then we basically came and say, let's build a semantic layer and let's first cover this BI use case. And we did that a couple of months ago. And now with the AI, it's not that let's go and build this AI and the data and everything, but now because we had the semantic layer and the BI use case, we just say, okay, so what are the use cases for the AI on top of that? Just like that, we didn't have to, because we are that composable, we are able basically directly to utilize what was built for the BI use case before they even knew what might be the AI use cases, like a couple of months ago. So that's what I really like about the composable.
Yeah, it allows you to build and deploy quickly and adapt quickly. Is really what it's all about. It's almost less of a technology advantage, and it's almost more of like a process and scale advantage. The way you do things, if you embrace composability, will change, and that's where you will get a lot of the advantages. We have this question from an anonymous attendee. I'm going to ask. I've read the question. I don't 100%. I'm not 100% sure what you're asking. So if you could just rephrase it a little bit, and then Pavel and I will discuss it after we talk about this next point here. So this is the end of the presentation. Thank you for sticking with us, and thank you for the questions that we got. Just some decision points when you try to make this decision. Should I buy or should I build? Okay. This is how I would think about it. You need to be honest with yourself. Do you have the skills to build? As you saw from the slide we showed at the beginning of the presentation, it is very complicated. And it may, oftentimes people will set out, they'll say, we're going to build our own, but we're going to keep it simple. That inevitably, it gets more and more complex as your users need more features. And so you need to just be really honest with yourself and do we have the skills to do this? Conversely, you also have to be honest with yourself. Does the off-the-shelf software really meet our needs? If good enough is, I've said this a couple of times, but if good enough is good enough for you, then maybe it does, right? And if you say, look, we're not trying to go above and beyond. We don't have a really specific or revenue driving analytics use case that we want. Instead, we need analytics as part of our app. We know that. And so let's just build some dashboards and get them in the app. Well, then maybe buy really does meet your needs. What's your overall strategy? Are you invested in open source or do you prefer vendors, right? Do you want to be able to switch technology frequently, or do you want long-term contracts with long-term support? That will help you make this decision. Likewise, is vendor support critical for your success? Do you know that when something breaks, you are going to need someone to call? And that could either be technically, like, hey, I know that my department needs the technical support, or it honestly could be a business process thing. Like if something breaks, we need to have someone who we can call in and maybe we can, it's the vendor's fault, right? Like that's a reality of some departments, that the vendor gives you support, but also helps you, helps give you some accountability to someone outside of your team. If you're building it all yourself, then you're the only point of accountability. And then finally, is good enough, or do you have a vision? And ultimately, that's what it comes down to in my mind. If you have a vision of what you're trying to deliver, then you need to embrace the composable approach and use tooling like good data in conjunction with other tools you may have, because obviously, as Pavel said, we're very easy to integrate with your existing tooling and stack where you need to. But if you have a vision, then you're going to need to really embrace this approach to deliver that vision, and that's in my mind what it comes down to. Is that last point is the most important one when it comes to making this decision. Pavel, what do you think?
Yeah, I agree. I have not much to add. I was actually thinking about the question we got in the chat, like,
Yeah,
might be the point, but I think the point is you can keep ClickHouse, and you can keep it for the data layer, perfectly fine. But if you think the ML AI in ClickHouse is just not enough, might be the case. But that's our composability. So if you have the semantic layer in good data on top of your ClickHouse, you can plug in any other suitable AI or ML model on top of that, on that semantic layer. Doesn't have to be from us because we are composable. So if you have your model trained somewhere else for that data, just plug it in the semantic layer and just use it as part of the analytics platform.
absolutely. Yeah, good answer, Pavel. Thank you. It was a good question, anonymous attendee. Thanks for that. All right, so with that, I keep hitting the thing in the wrong direction. I'm trying to switch between Windows and Mac mouse wheel, and it's driving me crazy. With that, we're going to wrap things up. So I want to thank Pavel for joining us today. This was Pavel's very first Good Data webinar. So thank you so much for joining us. Awesome insight that you brought to it. I really appreciate it. And listen, if you like this type of thing, we do these webinars most months. We're skipping August, but at least, for most of the year, you can catch us once a month covering these types of topics. Sometimes we'll talk about decisions like this. Should you build or should you buy? Sometimes we'll bring on industry thought leaders to get their take on what's going on in data, or we'll do product updates. But tune into this webinar series. There's a lot of great stuff happening here. Of course, follow us on social media. We're on all the socials, so follow us there. And if you'd like to meet us, of course, you can meet us coming up at a number of conferences. We'll be at Big Data Expo Utrecht. We'll be having a meetup in Prague, our Good Data meetup, September 16th. Our next webinar is September 17th for Q3 product updates. And then finally, you can catch us at Big Data London, September 24th and 25th. So with that, I want to thank you all for being such a great audience today. And we will see you next time here on a Good Data webinar. Thanks, everyone. Have a good summer and stay safe out there. Bye.
Thanks a lot. Bye.